Hey there, geometry. We're in Unit 2, Lesson 4. And the first thing that this asks us to do, you can look in your classwork, is to draw a triangle with these measurements. Now, if we were in the classroom, you'd be doing this with paper, pencil, a protractor, an eraser, straight edge with a ruler on it, because it is kind of hard to do. So first we want to do angle A, which is 40 degrees. So we're going to do this in GeoGebra, and it's still not going to be easy. So I need to make a segment AB. I don't know what dimensions to make AB yet, because we're going to go in the steps that they go into, and we'll deal with it as we deal with it. The next thing we want, angle A has to be 40 degrees. So if we look right here, I can make an angle with a given size. If I click on the leg and the vertex is going to be A, I want that to be 40 degrees. And I want that to go counterclockwise. And there we go. And I'm going to go ahead and make a segment on that AB prime, just because I want to be able to see it. Okay? Now we want angle B, which is 20 degrees. That's actually a little bit harder. So I'm going to put a point C here and see if I can, make a segment. And I'm actually going to measure this angle that I just made. A, B, C. Okay, that angle is 31 degrees. It's a little bit big. I'm going to move this in here so I can see it. Move that in there so I can see it. And then I'm going to drag this point C until I get 20 degrees. See how it's sliding along that segment? And I'm not, last time I couldn't get 20 degrees exactly. This time I did. Yay! So cool. Now angle C is 120 degrees. And if you remember, we know the inside of a triangle is 180 degrees. So 40 plus 20 is 60. That's awesome handwriting, isn't it? 180 minus 60 is 120. So angle C should be 120 without us doing anything, right? So let's just measure that angle. Angle measure. So I'm going to measure angle A, C, B. Okay. I'm going to measure angle A, C, B. And it is 120. We did not get lucky with that one. That is just pure math. Okay. Now it says segment AB should be 5 centimeters. We didn't make segment AB anything, so we're going to measure it. It's 6. Segment AC is 2. I need to make a new segment AC. I'm just going to go right over the top of it and measure it, and it's not going to be 2. It's 2.4. Not bad. Let's move that out here so we can see it. Nope, that's not what we wanted to move. Let's put that back in there. Put that right there. And now let's measure that last segment. Here it says AC or CB should be 3.7, 4.5. It's not. All right? I know all the angles are what they want us to be, but the sides are not. But watch this. I hope it works this time. It did when I tested it. Okay, my angles aren't changing, but my sides are. So all my angles are rigid, yet my side lengths are not rigid. Crazy, huh? Now it is going to be near impossible for me to get 5, 2, and 3.7. Like there I've got 5. I have 2. Well, apparently it's not impossible because I just did it on my first try. Okay? But I can make it go out. I can make it go again. I can actually hide that so it looks better. There we go. But yeah, I can move. Oh, I didn't want to. Well, it's okay. I can move anything. Oh, except that one. That's the one we didn't want to move. We had to grab point B. But point B deleted for some reason. All right. So what I want you to understand here is we drew a triangle with the correct angle measurements. And then we measured the side measurements and they weren't right. But we can drag one of the movable points around where the angles don't change and the side measurements do. So how many triangles can I, gosh darn it, how many triangles can I make out of those 3 angle measurements? I'm not going to be able to get it again. Let's see if I can. 120, 20, and 120, 20, and 40. How many different side measurements can I come up with? That's going to be close enough. With those 3 angles. Infinite. I can make infinitely many triangles that have rigid angle measurements, but not the same side measurements. Okay? As many as I want. See how all the sides are changing? Infinite. All right? Let's move on. Okay, info gap. We have problem cards and data cards. Do not show or read your card to your partner. Okay, hold on tight. We're moving over here. Nope, not there. Right here. Okay, let's talk through this is not the right one. Problem card, data card. We need to be in lesson 4. I wonder if I used the wrong one in the triangle transformation proof template. Okay, these are sometimes hard to find. Sorry. We want lesson 3, 4. Info gap? Was that it? Problem card, data card. All right, so we're just going to talk through them. Okay? Construct a triangle that is congruent to your partners. What's the least amount of information you need? Yep. All right. So the only way I can do this is to actually talk through it. Let's do this. Okay, I'm going to pause for a second. I need to get this into something I can write in. All right, let's work on this problem card. I have a dog laying next to me now that's panting because she just got back from a walk. So she's loud. Looking at this problem card, construct a triangle that's congruent to your partners. What is the least amount of information you need? If your partner gave you all the side measurements, all the side measurements, you would get the triangle correctly. If your partner gave you, let's change colors, a side, and the included angle. Think about if you had 2 pieces of spaghetti, okay, and you put one the right length this way, you put one the right length that way, you made the angle the correct angle. This part is going to be spot on, right? So you just did side, the included angle in between the 2 sides and the other side, and you would be able to construct the triangle. We learned in the GeoGebra activity we just did that knowing all 3 angle measurements does not work. Okay? Now, just moving on. So far we've done side, 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 angle, side. Let's talk about if we know an angle measurement, a side, and an angle measurement, could we do it? So if you had some spaghetti and you had a piece that is 3.2 centimeters long, and you had another huge piece of spaghetti, but you made it 60 degrees from your given one, and you had another huge piece of spaghetti, but you made it 70 degrees from your given one, you would cut the spaghetti right here, and your triangles would be the exact same size, okay? So we know if we have 2 angles with the included side, which we have an angle, and the included side, it's in between the 2 angles, we can get 2 triangles that are congruent. Now let's see, we did side, 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 angle, side, angle. How about angle, angle, side? Okay, follow me. If I gave you some spaghetti and I said, okay, we have super duper long piece of spaghetti, we don't know how long it is, and a super duper long piece of spaghetti, but we knew that the angle was given. And then a super duper long piece of spaghetti, but we knew what angle was given. And we knew one of the lengths. Okay, so actually I'd want to erase. Sorry, so many things going on. We knew that, that's not an eraser, that's a blue pen. Do you hear my dog? Oh goodness, still a blue pen. Eraser. We knew that that 6.8 centimeter was correct. So if that 6.8 centimeter was correct, let's try it in red, see if we can get it right. This one was given. We know the measurement of this piece of spaghetti, we know this angle, and we know this angle. All right, super duper long piece of spaghetti. Okay, super duper long piece of spaghetti, but ooh, let's do this. Can I grab that piece of spaghetti? I don't know if I can. So, oh, it'd be so much easier with spaghetti, wouldn't it? On that note, we are having pasta for dinner tonight. I know you care. All right. So this last piece of spaghetti, we don't know how long it is, but we know that it has to stop at point B, and it has to be 142 degrees. Okay, so that tells me where I need to cut my spaghetti. I need to cut all of that off, and I need to cut all of this off. All right, and what I need you to remember is that when you know two angles and the not included side, so two angles and the side not included, then you're going to have congruent triangles. All right? All right, let's go back to this. Okay, I'm not going to do that. So here, too little information. Jada and Tyler were playing the info gap using card 3. Tyler asked, can I have two sides and an angle? Yeah, we can have two sides and an angle. We did that. We did side, side, and angle, side just fine. Sorry. Okay, I need to apologize. Family came home. Chaos ensued. We ate dinner. I'm now outside because the family's home and it's loud and I'm blinded by the light. So we're just going to start over on 4.3 on this little part. Let me get my eraser out. Not sure what I was talking about, and with Loom I can't rewind my video to see what I was doing before. So let's just start here. So Jada and Tyler were playing the info gap using card 3. Tyler asked, can I have two sides and an angle? Jada told Tyler that one angle was 16 degrees and one side was 5 and one side was 4 centimeters. Here is the triangle Tyler made. So here I've got 16 degrees, 5, and 4. So that is actually, that didn't work. Angle, side, side. Oh, nope, we're not doing that today. Look at me being on top of things. So what that is angle, side, side, which we're going to write backwards. The important thing here that I'm denoting is the angle is not included. That means it's not in between the two sides. The angle's on the outside. So I could side, side, angle. Okay, so here he did side, side, angle. Side, side, angle is not a triangle. Hold on. Triangle congruency statement. And what I've been telling my geometry students for as long as I've been teaching geometry, if it spells a bad word, it doesn't work, okay? So if you look at side angle backwards, which I almost drew, but I didn't, it spells a bad word, therefore it's not a triangle congruency statement. Now, we've already gone over the fact that angle side is a triangle congruency statement. If we were doing, let's say, angle side, the only way I could construct a triangle with 21 degrees, 143 degrees, and 5 is the correct way. It will be congruent. Okay, angle side works. Side angle does not, because if it spells a bad word, it doesn't work. Okay? Did Tyler do anything that didn't match Jada's instructions? No. Tyler followed Jada's instructions perfect. But what we need here is, that is side angle. It doesn't work. So it can be done in a different way. So Tyler followed instructions. Those instructions do not work, okay? How could Tyler have made a more specific request for two sides and an angle so that his triangle would guarantee to match Jada's? If he would have done side, angle, side, angle, side, or angle, side, it would have worked perfectly, okay? It's just important how you ask for things. This second option, the side is in between the two angles that he gets. This third option, the angle is in between the two sides. That's what we call the included angle or the included side. It's in between. All right? And side angle does not work because it spells a bad word. All right, and our summary. Two pairs of corresponding sides with the angle between it. Two pairs of corresponding angles with a side between it. Three pairs of corresponding sides. And they didn't give angle, side, which also works. That might be in a future example, future lesson. All right, that's all we're doing for today. Good job.